Hello friends, welcome to Susan and John MathTube. In this video, we're going to work out some very important exam questions for harmonic functions. In the last video, we learned how to create u from v and v from u, and we also learned how to create the complex function u plus iv given one of them. Anyway, in today's video, we are going to learn some repeated question in many universities around the world. So let's start with the first one. If you want to write a common question, you can write like this: find the harmonic conjugate and also the complex function u plus iv. And what I am trying to tell you is u is given. Prove that it is harmonic. What do you mean by harmonic? Yeah, the sum of the second order derivatives will be 0. Or a function which will balance or satisfy the Laplace equation is called a harmonic function. Now the second thing. If u is given, they are asking you find v and also the function u plus iv. If v is given, prove that it is harmonic and find u in such a way that u plus iv is analytic. So let's start. I hope you're all ready with a pen and a paper. Write the first question. So we have u is equal to x cube minus 3xy square plus etc. long function. So I'm going to differentiate partially with respect to x. So we will get 3x squared minus 3y squared plus 6x minus 0 plus 0. So that u xx will be 6x plus 6. Similarly, uy will be equal to minus 3x multiplied by 2y minus 6y. So that when you differentiate it again, we will get minus 6x minus 6. So add them up and you'll be able to prove that the given function u is harmonic. Okay, now step number 2. U is given, so we have to find v. So let v be the harmonic conjugate. So I'm going to write f of z equal to u plus iv. Let it be analytic where v is our required harmonic conjugate. Now do you remember the step? If you remember, pause it, try it, and at the last check whether your answer is matching with my answer. So f dash of z equal to ux plus I vx. That is f dash of z equal to ux minus I uy. In case you are confused, pause this video, watch the last video and come back. In the last video, I clearly explained how we get these steps. So f dash of z equal to ux. Where is our ux? Yeah. So when you plug in, you will get this stuff. Now apply Mill-Thomson method. So f dash of z is equal to 3z square minus 0 plus 6 times z plus 0 plus 0. So the imaginary part will become 0. Now integrating, because we need the function, integrating, we get f of z equal to 3 times z cube by 3 plus 6 into z square by 2. So that will be 3z square plus c. So we have the function. By the way, in your applied mathematics, for engineering students, for physics students, for other applied mathematicians who use complex analysis, this method is very important. Because in many real life scenarios, you may be able to model u. And using u, you will be able to find v. Because we know this method. And using u and v, you can find the complex potential function. We will do that in the coming video. Okay, Now let me find u and v. So I'm going to separate it. F of z equal to u plus iv. That is x plus iy the whole cube plus 3 times x plus iy the whole square plus c. U plus iv equal to plus 3x square iy plus 3x I square y square plus I cube y cube plus 3 times x square plus 2x iy plus I square y square plus c. And once more quickly, what is root under minus 1? I. What about I square? Minus 1. What about I cube? Minus I. And you plug in all those values, we will get u plus iv equal to x cube plus I 3x square y. This will become minus 1 minus 3x y square. This will become minus I y cube plus 3x square plus I 6xy and minus 3y square plus c. Now I want v. So I'm going to pick the quantities along with I, including that negative. That's it. So we got the value of v. 3x square minus y cube plus 6xy plus c. Okay. Now let's go for the next question. So please copy the question. This question has confused many students. In our first video in complex analysis, we learned the meaning of amplitude. And in that video, I even gave you a method so that you can find the modulus and amplitude. Another word that we used instead of amplitude is argument. And the value of argument is, can any one of you tell me? Anyway, comment below whether you were able to tell without looking at the hint. So the argument is tan inverse y divided by x. Now this is a trap. Most of the weak students have confusion in what is the amplitude. So you must know that the modulus is root under x square plus y square and the argument is tan inverse y by x. Okay, so let's start. So v is equal to tan inverse y by x. Okay, now for the weak students, can you tell me how do you differentiate tan inverse x with respect to x? I'm sure your answer is 1 divided by 1 plus x square. Second question, how do you differentiate tan inverse something? So your answer will be 1 by 1 plus something squared. No, that is not enough. Because according to chain rule, you should multiply this by the derivative of something. I'll give an example. Suppose you want to differentiate tan inverse of sin x. What I see here on the board is tan inverse something. The derivative of tan inverse something is 1 by 1 plus same quantity squared. That is not enough. Multiplied by cos x. Okay, now step number 2. Now the second question is, what is the derivative of 1 by x? If you don't know, I'll strongly recommend note it down. The derivative of 1 by x with respect to x is minus 1 by x square. You can derive it, but if you can memorize it, it has some benefits. Now the last question is, how are we going to differentiate the given function? So I'm going to write Vx because we have to prove that the given function is harmonic and we have to find the harmonic conjugate and the complex potential. So Vx is, can you see this is tan inverse something? Are you able to see tan inverse something? Yes. So the derivative is 1 by 1 plus same thing squared multiplied by, how do you differentiate y divided by x? Y by x is y multiplied by 1 by x and y is a constant. Do you know why? because we are differentiating with respect to x. X is the hero, y is just a constant. So y multiplied by minus 1 by x square. Now simplify this, take LCM, etc. etc. I am skipping those steps. We will get Vx is equal to minus y divided by x square plus y square. Now comes another trouble, the second order derivative, Vxx. Now look at this. If you want, you can differentiate this without quotient rule. Because the numerator does not have x, we are going to differentiate with respect to x. But some students love quotient rule and I am going to support them now. Let's apply quotient rule for such students. Are you able to see u by v? But remember, the numerator is a constant. So what I'm going to do is, I'm going to write denominator square because I hope you remember u by v rule. Denominator multiplied by derivative of the numerator. Wow, that is 0. Minus numerator multiplied by derivative of the denominator. That will be 2x. And that's it. So Vxx is equal to 2xy the whole divided by x square plus y square the whole square. Now we are going for Vy. So V is equal to tan inverse y by x. And Vy. Now who is the hero? Y. Anyway, this is tan inverse something. So 1 by 1 plus same thing squared. Multiplied by, what is the derivative of y by x? I'm going to write y by x as 1 by x multiplied by y. Now remember, x is a constant. Now y is the hero. So the derivative will be 1 by x. Simplify, simplify, simplify till you get x divided by x square plus y square. Now the next step, we have to differentiate this again with respect to y. You can apply any method you like. You don't have to apply u by v rule. Because we are differentiating with respect to y, partially differentiating. So the numerator is a constant, you can keep it, you can apply the formula 1 by something. But most of the average students love quotient rule for this problem and that makes them feel comfortable. So let's stick to them. So the denominator squared is here. Now come on, tell me, how do you apply quotient rule? Denominator multiplied by 0 minus numerator multiplied by 2y, and I got minus 2xy the whole divided by x square plus y square, and that makes me very happy because I proved that the sum is equal to 0. Hence the given function is harmonic. Point number 1. Now I'm going to find the harmonic conjugate. So what will be the dialogue? Let u be the harmonic conjugate so that u plus iv is analytic. No, let's give it a name. So I'm going to assume, let this be the required analytic function, and this is exactly what I'm searching for. Next step, the derivative ux plus ivx. Oh, wait a minute, look at the question. They gave v, so I have to convert everything in terms of v. No problem, we will write the CR equation, ux equal to vy, uy equal to minus vx. So the derivative goes like vy plus ivx. So the derivative will be equal to, what was vy? X by, okay, x divided by x square plus y square plus I. What's the value of vx? Vx is minus y divided by x square plus y square. Now I'm going to apply Mill-Thomson method so that I'll get my derivative in terms of z. So z divided by z square plus 0 square. That part becomes 0 because 0 divided by something will be gone. So I end up with the derivative is equal to 1 by z. Now what will I do? Okay, integrating. The function is equal to Come on, come on, come on. Tell me what is integration of 1 by z? That's it. F of z equal to log z plus c. So we got the complex potential. We got the whole function. Now one more job. We didn't find u. So I'm going to write u plus iv equal to log z plus c. Can anyone tell me how are we going to separate it? We learned this as a special problem, maybe in lesson 4 or 5, I don't remember, but we already did it. If you're going to tell me you're going to replace z with x plus iy, I'm really sorry, you are wrong. We have to convert this into modulus argument form. Do you remember? I told you z to the power n and log z are very important questions because most of the professors tend to ask this question in your university exam. Anyway, I'm going to convert this into the modulus argument form. So I'm going to plug r e power I theta plus c. So u plus iv equal to, what is log a into b? Log a plus log b. And that reduces to log a plus, this will become I theta log e. Log e is 1. Don't forget log e is 1. One more step and we are there. What is the value of r? Root under x square plus y square. And what is the value of the argument? Theta, tan inverse y by x. Now, do you still remember the question? We want the value of u. That means this is our answer. Plus c. Of course, don't forget plus c. Okay, now we are ready for the next question. And that is a very long one. Okay, so we have the function u is equal to e power x, x cos y minus y sin y. We'll jump directly to the differentiation part because many students struggle with the differentiation part for this problem. So I'm going to color it because I'm planning to apply the product rule. Look at this. I can see x in green and x inside the blue. So I am going to apply product rule. So first function multiplied by derivative of the second. But look at this. Cos y is a constant. So the derivative will be cos y multiplied by 1 minus the whole thing is a constant. So it's going to be 0. So that's it. Plus, now the blue function. You remember product rule. Green, derivative of blue, done. Now blue. What's the blue function? Can you please read it? X cos y minus y sin y multiplied by e to the power x. Now, if you want, you can take this e power x common so that when we differentiate it again, we'll feel slightly comfortable. So cos y plus x cos y minus y sin y, and that will be ux is equal to e power x x plus 1 cos y minus y sin y. Okay. Now uy. By the way, normally they will not ask you to prove that this function is harmonic because this question itself is like very long. Usually they will not ask you to prove that it is harmonic, but be ready for that. In case you want to prove it is harmonic, it's okay. This is again another blue and green, and then again apply product rule, and that's it. You'll get uxx plus uyy equal to 0. Anyway, I'll teach you how to differentiate with respect to y. Now this is awesome. Look at this. This green is a constant. We are going to differentiate with respect to y. So the green is a constant. So I keep the green as such and I'm going to differentiate the blue one. And x is a constant. So the derivative of cos y will be minus sin y. Minus, I'm going to put a bracket. Can you see y multiplied by sin y? It is a product. You have to apply product rule. So y cos y plus sin y times 1. Once more I'll repeat, practice a lot. This differentiation gives trouble for some students. Anyway, once more I'll repeat, we are differentiating with respect to y. So the green thing is a constant. And inside also look at the first term. Cos y is a function and x is a constant. So we get this. And then y cos y plus sin y into 1. Now let's rearrange it. E power x. All the terms are negative. So I'm going to take this negative outside. And I'll get x sin y plus y cos y plus sin y. And uy will be minus e power x. Sin y is common, so we'll get x plus 1 sin y plus y cos y. It's very similar to the other derivative. Anyway, I'm not going to prove that it is harmonic, but try it. Maybe in your exam they are going to ask only prove that it's harmonic. Anyway, give it a try. I'm going directly for the complex potential. So fz equal to ux plus I vx, and we are given u, so I'm going to convert the derivative to ux minus I uy using CR equation. So the derivative becomes the whole stuff plus I into the whole stuff, but it's a very long expression. So I'm directly going to apply Mill-Thomson method. Don't do like that in exam. In your examination, presentation means a lot. But my job is to make you understand. But in the exam, your job is presentation. You have to present properly. Okay. So I'll replace x with z and z plus 1. Cos 0, that will be 1. Minus the whole stuff will become 0. Minus will be plus. Can you see this minus and minus will be plus? Plus I multiplied by e power z, and sin 0 is 0. Oh wow, that part vanished. Still, this function is a troublemaker. Can you see we have a product here? Okay, so we got f dash z equal to e power z into z plus 1. So I'm going to integrate f of z equal to integral z plus 1 multiplied by e power z dz. Do you still remember why I kept like that? Because the order will be algebraic function or the polynomial and then exponential. Anyway, I'm not going to apply Eilert rule. I'm going to apply the shortcut Bernoulli's. You'll see that Bernoulli's trick in Fourier transforms and Fourier series. So f of c is equal to first function integral of second minus differentiate this stuff. So we get 1 e power z plus c. See, in a single step. So f of z equal to e power z is common. So z plus 1 minus 1 plus c. So we get f of z equal to z multiplied by e power z plus c. So we got the complex potential. Now the last step. What's the last step? We have to separate. So u plus iv equal to x plus iy multiplied by e power x plus iy plus c. U plus iv equal to don't be lazy, pause the video, try it. This is an extra important problem. So e power x multiplied by e power iy plus c. What is e power I theta? By now you will be like really good with these things. So we get x plus iy, and I keep e power x over here, and e power I theta cos theta plus I sin theta. And now I'll distribute the whole stuff. So e power x, can you see I'm going to distribute this? So I'm going to get x cos y plus I x sin y plus I y cos y. I square is minus 1, so y sin y plus c. Now do you want u or do you want v? Of course v, because u is given. That means I want to combine the quantities along with I. So here we go. The answer is x sin y plus y cos y multiplied by e power x. Now we have two questions remaining. I'm leaving those questions for you. Try it, and if you get the answer, do comment below. If you find the videos useful, comment below. Do subscribe and support. I'll be back with more videos like this. So till then, my friends, bye.